This is lesson 7-2, and what we're going to be doing in this lesson is graphing exponential functions using translations. So we're going to use the same types of translations that we did in the first three chapters, and so if you know that, this should be relatively easy. Okay, first thing we're going to look at is the function y equals 2 to the x. This will be our parent function. So we want to put a few points on here. So let's say x is 0. If x is 0, we have 2 to the 0 power, which is 1. If x is 1, we'd get y is 2. If x is 2, we would get 4. If x is negative 1, we'd get a half. So we know we have a graph that's approaching the x-axis. So here's our asymptote. So the curve is an exponential growth. So it looks like this. If we put a 3 on the front of this function, then what it does to the function is it stretches it vertically. So each of our points, all of our y values get multiplied by 3. So the point that was at 0, 1 is now at 1 times 3 is 3. This point that was at 1, 2 is going to be at 2 times 3 is 6. Every point gets the y value gets multiplied by 3. So this point that was at 4 will be now at 12. So it's going to be up here somewhere. This point that was at 1/2 will be at 1/2 times 3. So that's 1 1/2. So we get a curve that's similar to the previous one. It still approaches the x-axis on the left. And it's still a growth function. It's just much more rapidly increasing on the second function. So the 3 on the front, the a value, causes the graph to stretch in a vertical direction. So here are some other a values. To make our parent function, we're going to just make this simple, and we're only going to put in 2 values. We're going to have x equals 0 and 1, and then we will calculate the parent function with just those values. So when x is 0, we get 3 to the 0 is 1, and when x is 1, we get 3 to the first is 3. So in our parent function, we would have a point at 0, 1, and another point at 1, 3. We know we have a curve that goes like this. We know it approaches the x-axis, exponential growth function. So now, what does the negative 1/3 do to the graph? Well, the negative is going to make the whole thing reflect across the x-axis. And the 1/3 then will make each of our y values be multiplied by 1/3. So our first point is going to, well, we're multiplying by a negative here. So our first point will be at negative 1/3, and our second point will be at negative 1. So the point that would have been at 0, 1 for the parent function is now at 0, negative 1/3. The point that would have been at 1, 3 for the parent function is at 1, negative 1 for the translated function. Our curve still approaches the x-axis on the left, but now it curves below the x-axis. So the domain to this finished function is all real numbers. But our range here is that the y values will only be negative, so y is less than 0. Okay, on our second function, the parent function, y equals 5 to the x, using 0 and 1 is going to give us 1 and 5. We take each of these values and multiply them times negative 0.5. So that's going to give us negative 1/2, or negative 0.5 for our first one, and negative 2.5 for a second function. So again, the graph reflects across the x-axis. So at 0, we're at 1/2. At 1, we're at negative 2.5. And the curve is still approaching the x-axis, and it's still going away from the x-axis on the right. So the asymptote here. Okay, Domain to this function is still all real numbers. The range is all real numbers where y is less than 0. The graph never goes above the x-axis. Okay, in these functions we have horizontal translations. So, I'll write that down here. We know they're horizontal because we have the parenthesis with the x in it. So whenever you're looking at a translation where it's in the parentheses with the x, it's a horizontal translation. And the -4 tells us we're translating to the right 4 units. So our parent function, again, would be with 0 and 1 and just 2 to the x. Don't worry about the -4 yet. For the parent function, it's just y equals 2 to the x. So 2 to the 0 is 1, 2 to the first is 2. So I have these points at 0, 1 and 1, 2, and I know it's an exponential growth, so it's going to look something like this. The translated function is going to move each point right 4. So I'm going to take this point and I'm going to go over right 4, right there. Take this point, go right 4, right there. The new curve is going to look like this. Asymptote is still on the x-axis. Domain is still all real numbers. Range is all real numbers where y is greater than the asymptote, which was at 0. So the green is our final answer. The blue was the parent function. And so there's our translated function. In this next example, we have the parent function using 0 and 1. We're going to have 4 to the x power. So 4 to the 0 is 1. 4 to the first is 4. So our parent function is going to start at 0, 1 and 1, 4. The +2 on this tells us that each of these functions are going to go left 2 units. Or each of these points go left 2 units. So the first point is going left 2 units. Second point, left 2 units. So the curve is going to look like this. Asymptote, still on the x-axis. Domain is still all real numbers. Range is still all real numbers where y is greater than 0. Okay, I'm going to stop this video here. We'll continue with vertical translations next.